Picture the Earth spinning in space, and at its very top, over the North Pole, a massive swirl of icy air is always in motion. This is the polar vortex, a giant, invisible spinning top of cold wind, high above us in the stratosphere. Unlike storms you see on weather maps, the polar vortex is a vast, low-pressure system that circles the pole, especially strong in winter. A sharp temperature difference forms a powerful jet stream, acting like a barrier that keeps the cold locked up north. When the vortex is strong, it keeps the coldest air contained, allowing milder winters in Europe and North America. But when disturbed, it can unleash winter's fury. The polar vortex is a wonder of our world's atmosphere and the starting point for understanding Europe's most extreme winter weather. High above the clouds, in the stratosphere, the polar vortex is surrounded by a powerful jet stream, the polar night jet. This jet stream acts as an invisible fence, racing around the vortex and keeping the frigid Arctic air trapped. When the vortex is strong, this fence is solid, preventing cold air from spilling south. This balance allows Europe to experience typical winters, with the Arctic deep freeze kept far away. The strength of this fence depends on the temperature difference between the Arctic and the mid-latitudes. A colder Arctic and warmer south create a fast, stable jet stream. This system is nature's way of managing heat, keeping extreme cold contained during the darkest months. The polar vortex and its jet stream are not random. They're a structured, crucial part of global climate. When this system works, Europe gets a normal winter. But if the fence weakens, everything can change. That's when the weather can take a dramatic, frigid turn. Sometimes, the polar vortex gets knocked off balance, like a spinning top that starts to wobble. Disturbances from below, like atmospheric waves from storms or mountains, can disrupt the vortex. This can trigger a sudden stratospheric warming, rapidly heating the polar air and weakening the vortex. The jet stream slows and becomes wavy, breaking the invisible fence. Frigid Arctic air escapes, stretching south in massive cold tongues. The result: severe, prolonged cold spells and Europe's most extreme winter weather. In early 2018, Europe was hit by the Beast from the East, a textbook example of a weakened polar vortex. It started with a sudden stratospheric warming that split the vortex, reversing the usual jet stream winds. A blocking high over Scandinavia diverted mild Atlantic air and pulled in frigid Siberian air. Snow blanketed the UK and even Rome, while temperatures plunged across the continent. The disruption caused chaos. Transport halted, schools closed, and daily life was upended. Scientists saw the warning signs weeks in advance, tracking the stratospheric changes. The event showed how a shift 30 kilometers above could impact millions on the ground. The Beast from the East wasn't a freak, just a classic polar vortex breakdown. It highlighted the deep connections in our climate system. It sounds like a paradox, but a warming Arctic can actually mean colder winters in Europe. The polar vortex relies on a sharp temperature difference between the Arctic and the south. But the Arctic is warming twice as fast as the rest of the planet, a process called Arctic amplification. Melting sea ice means less sunlight is reflected, more is absorbed, and the temperature gap shrinks. A weaker temperature gradient leads to a slower, wavier jet stream. This makes it easier for cold Arctic air to escape and reach Europe. Think of the Arctic as a freezer left slightly open. It's not as cold inside, but the kitchen can get a sudden chill. So, even as the planet warms, Europe can still get hit by bursts of intense cold. The science is complex, but the evidence is growing. Arctic changes are reshaping our winters. Understanding this link is crucial for forecasting and preparing for future cold snaps. Forecasting the polar vortex is one of meteorology's biggest challenges. Scientists use satellites, weather balloons, and computer models to monitor the stratosphere for signs of disruption. Sudden stratospheric warming events act as early warnings, but there's a lag. Weeks can pass before surface weather changes. This window allows forecasters to issue cold weather outlooks, but it's not an exact science. Not every stratospheric event leads to a cold snap in Europe. Sometimes the cold heads elsewhere, or the vortex recovers. The atmosphere is chaotic, so predictions are based on probabilities, not certainties. Still, advances in modelling are improving long-range forecasts. These forecasts help governments, energy providers, and farmers prepare for winter's worst. Early warnings can protect infrastructure, crops, and lives. Predicting the vortex is about buying time to get ready. It's a vital tool for managing the risks of extreme winter weather, and it's getting better every year. The polar vortex isn't just a winter phenomenon. It exists year-round, but changes with the seasons. In summer, the North Pole's constant daylight weakens the vortex, and the jet stream breaks down. The southern polar vortex over Antarctica is stronger and more stable, thanks to the continent's geography. This stability means fewer outbreaks in the southern hemisphere, but it also creates the right conditions for the ozone hole. Special clouds form inside the Antarctic vortex, enabling chemical reactions that destroy ozone. So, the polar vortex shapes not just weather, but also the chemistry of our atmosphere. Its behaviour at each pole is different. The north is erratic. The south is a cold, stable giant. Both are essential to Earth's climate machinery. The vortex influences temperature, storms, and even the health of the ozone layer. It's a key player in the planet's atmospheric drama. Understanding the polar vortex isn't just for scientists. It matters to everyone. Early warnings let us prepare for extreme cold, check on neighbours, and protect our homes. Governments and industries rely on forecasts to manage energy supplies and keep transport running. Farmers use them to shield crops from sudden freezes. Accurate predictions turn winter shocks into manageable events. Food security, infrastructure, and daily life all benefit from better forecasting. Living with the vortex means living with uncertainty, but also with growing foresight. It's a reminder of our planet's dynamic nature. The vortex isn't a monster, but a force to understand and respect. By studying it, we learn to live in harmony with Earth's rhythms. The polar vortex is a vivid example of our planet's interconnected climate. A shift high above the pole can shape weather for millions far below. Everything is linked: stratospheric winds, Arctic sea ice, European winters. The vortex is just one piece of a vast global puzzle. Its behaviour is influenced by oceans, mountains, and even tropical weather. Changing one part of the system sends ripples everywhere. As the climate changes, so does the vortex, and so must our understanding. Studying the vortex reveals the complexity and power of Earth's atmosphere. It reminds us that we're all connected, from the frozen poles to the cities and fields of Europe.